everyone. Thank you for coming to this presentation. It's called Automating Compliance and Infrastructure Plumbing, Tackling the Boring Stuff. And I should mention, when I say boring stuff, I mean from the perspective of a traditional developer, such as initial server provisioning and identity management and that kind of thing. My name is Oskar Kristiansen, and I do platform engineering at Saxo Bank. So, for a little background, I want to quickly tell you about Saxo Bank. It was founded in 1992 in Copenhagen, and it pioneered online trading in 1998. We were the first online trading platform in North Europe. Yeah, we have a global presence. We have over 1 million clients, over $100 billion in assets, and we operate in 15 countries. And our platform provides regulated access to over 71,000 financial instruments. So all of that to say that Saxo Bank has a lot of legacy, a lot of different systems. We have lots of complexity, and we have a lot of compliance requirements in Saxo. So to tackle these challenges, we have created what I will present today, which is the Saxo Blueprint, we call it. So it provides centralized configuration with a single source of truth and a service definition for all applications running in the bank, which at the current moment is about 1,400. And on the sort of, with these as the data input, we do automation. We automatically provision resources and provide the required permissions for the applications to run and interact with each other. We do this using continuous reconciliation, so we always try to align which resources are actually provisioned with what the service definition states. And we do it in Git, so we have version control, which enables change tracking and auditing, which we are required to do. So why do we have Service Blueprint? So since we have been a technology company for over 25 years, we have a lot of different ways of doing things throughout the time. Originally, it was mainframe setups, and then it was a lot of on-prem, and then a lot of virtual machines, especially in Azure, but also EC2 instances in AWS and even in Google Cloud as well. And lately, of course, we use Kubernetes to run our infrastructure. But these things are not so easy to change in a bank, so all of it kind of has to run together at the same time. So we had manual identity and role assignments, which is, it's both takes time, but it's also kind of dangerous to have, since if you want to change things or you want to clean things up, it can cause a lot of issues if you don't have sort of a clear static state. It also makes it difficult to audit and track compliance. We use ServiceNow, we have for a long time as our change management system. And if you have to audit sort of major projects that have been alive for a long time, it's very hard to go through all the tickets concerning it and different business applications that play together in different ways. It's also very drift prone, since whatever you ask for manually, maybe something breaks or something needs to be modified in the future, and the state of the provision resources won't actually be what it says in the ticket. And of course, it's slow. We had some provisionings of servers taking several months in some cases after the initial request. And it also provides very poor feedback to developers. If you send off a ticket in ServiceNow, or you send off an email to a server infrastructure team, and then you hear back a few months later, it's very hard to kind of get an overview of your actual infrastructure as a developer. And lastly, which has become very important in recent times, it always was, but now also in terms of compliance after DORA, which you might have heard about, is that disaster recovery in such a system is very challenging. since you would have to traverse all the individual requests and go through ServiceNow and see all the change requests and try to piece together how the actual infrastructure should look. And then afterwards go through and click through all the various UIs to actually stand it up after this disaster has occurred. So our answer to this, to all these challenges, is what we call the Saxo blueprint. And it has 3 parts. It has the service catalog, which is just a a Git repo with a set of YAML files in a centralized location. And these YAML files, they are based on the Spotify Backstage YAML definition, which we'll come back to. Then we have the blueprint automation, which is a suite of operators running in Kubernetes, which provisions infrastructure on the basis of what it says in the service definitions. And then we have what we call DevReach, which is just a Spotify Backstage instance we run, which provides graphical overviews of all the applications and their relationships. And of course, as you know, it gives us the opportunity to integrate all kinds of different Kubernetes monitoring and Sysdig and anything you can think of, really. That's kind of our golden path, but what we found is that for some things, it's very annoying for developers to have to go through a centralized and sort of formal process like this. So in addition, for example, with permissions to databases which are just one-to-one with some service that developers themselves own, we provide Helm templates so they can just provision the access to it right in their own tenant repositories. This is how the service catalog look. If you're familiar with ServiceNow terminology, then the folders are business applications, and within them are YAML files, which are individual application services. So changes are, of course, done via PRs, which allows, again, the tracking, and you can go through and see the discussion and who requested changes and who approved them in an audit, in an internal audit. It also allows us to do things like this, where for a change where somebody might just want to change the description of their service, it's very easy to get a change like that through. They don't need a lot of approvers. But for a change like this, where they are requesting to change the lifecycle to production, which is a prerequisite for deploying in our production environments, we draw in both the enterprise architects and the global command center, we call it, which is basically the global monitoring guys who wakes people up in the middle of the night if something is burning, as well as the security people who will approve it first. This is kind of an overall architecture in a slightly simplified way. We have the service definition files. We have some processes running which enrich them slightly, so we don't need so much detail inside the service definitions, which developers actually don't really care about. And then it also overlays certain environment-specific configurations. So you can have different different configuration in development to what you have in live, for example. And then in a GitOps approach, we ingest them to Kubernetes and we create what we call blueprints, which are custom resources in Kubernetes. Then our blueprint operator picks it up and it creates more more granular custom resources to request different things. For example, Kafka or namespace request. And then for each of these requests, individual operators will pick them up and actually provision the resources. And we will take a look at some examples of this. So I'm sure you already know, but I just want to make sure we're on the same page. So since we heavily use the operators inside Kubernetes, I want to quickly describe it. So operators in Kubernetes, they continuously watch the states of resources like pods and services in sort of the vanilla version of it. And it uses controllers to compare the current state with the desired state and automatically make updates or changes to ensure that the system remains in agreement between the two. We do exactly the same, except our requests are called something like Azure SQL request or Kafka ACL request. And our controllers, they do do some changes in Kubernetes, but they will also do provision SQL identity assignments in Azure, for example, or Kafka topic permissions inside our data hub. So here's a sample service definition. I hope it's not too small that you can see it. So I'll go through a few examples of what we're able to provision on the basis of this. So this one is annotated with a namespace, which lets us know that this application is intended to run inside Kubernetes and inside a namespace. So when we see this, we create a namespace request. And our namespace operator will pick it up. And of course, it will create a Kubernetes namespace with all the sort of predefined configurations we have around that. But beyond that, it will also create an elastic space, so people can start ingesting their logs immediately. And it will create and scaffold a tenant. We use a Flux setup in our container platform. So they can immediately upon creating the service definition with this, they can start provision things in our dev and test environments inside Kubernetes. It will then also call what we call a AD group request custom resource, which our AD operator will pick up and create a group inside Active Directory and populate it with the members that was defined in the service definition. All our service definitions have a globally unique short name, and when we see this, we will create a service account request, which again is picked up by our AD operator, we call it. So that will create a Kubernetes service account, and it will create an Active Directory service account. And then it will create a federated identity credential custom resource, which our cross-plane operator will pick up and create a managed identity inside Azure, which we use to assign a lot of things in Saxo. And then we'll take all this information and write it back into container platform, such that with the role bindings, you can assign permissions to the managed identity or the service account inside Kubernetes. Okay, so the way we do relationships, there's this consumes and provides API methodology in the backstage API in the backstage YAML format. So relationships are all defined via APIs. So in this example, you can see it's type gRPC, and it's simply matched on the name. And you can see there's an annotation which lets us know that in order to interact with this API, you need this Microsoft Graph role. When we see this, when someone provides it, we create what we call a gRPC root request, which our DNS operator picks up, and using a Kong gateway inside Kubernetes, we create a root. And then using Cert Manager, we provision a certificate for this root, which is in agreement with the certificates on the external servers, on the external VMs. And we're also using external DNS, registers it in our internal DNS. So when you say in your service definition that you're providing a gRPC API, you actually have a callable API with a host name that people can call. Then, when someone else consumes this API, we create an Enter ID role assignment custom resource, which the operator picks up, and it actually creates the role assignment inside Microsoft Enter ID. So that means when someone provides a gRPC app and someone else consumes it, there's actually an API that you can call, and you are actually allowed to call it and know how to call it. We do something similar for Kafka. This is a Kafka example. When we see this, we create a Kafka ACL request, which our operator picks up, and it writes it into our data hub, which is run by our DBA people. It takes the IDs of the managed identities that we can derive from the service definition, and it writes it into ACL readers and ACL writers, which then their GitHub approach takes over from there and provisions the access. You'll notice also in our service definitions, we have a lot of metadata, stuff like our CMDB CI ID, which ties it back to ServiceNow, our change management system. We have the lifecycle that I talked about earlier. When you switch it to production, we have a whole formal process where we include security and architects and so on. But people are actually able to deploy things in development and testing environments very quickly, as long as the lifecycle is set to implementing. There's very low requirements for creating your service definition in the first place and get to developing. Then we also have which groups are responsible for what, which developers are primarily working on it, and so on, as well as the criticality, which lets our command center know sort of how much alerting they should do when something breaks. This also allows us to sync back and forth to ServiceNow, which is very important in our organization, especially, we have had it for a long time, but also because Git is a good way for us to track the changes and be able to audit internally and show that we are in compliance. But for certain business people that also have to interact with our applications, they're not used to this whole Git workflow, so they still have their known interface through ServiceNow. So things sync back and forth all the time, so they're always equal, and you can create changes through either side. And you can even create a service definition in the first place from either side. So having our setup in this way allows us to delegate a lot of responsibility, and it also allows us, frankly, to automate a lot more than we would otherwise be able to. Our team, the platform team, we don't have expertise as the DBAs does, or the monitoring people with Elastic, or even necessarily the cloud team in our cloud center of excellence. I should mention that we are a big sort of a Microsoft shop for the most part, so our operators are actually written in a .NET framework called CubeOps, which is basically just the .NET version of the Go operator framework. And what we've done is that we've wrapped it with our custom resource definitions, as well as a bunch of sort of useful methods that we use, and deployed it as a NuGet package. So other teams can create automation based on our service definitions by just implementing the reconciliation method. So they can basically contribute very easily. So what about monitoring and the feedback that I mentioned to begin with? So first of all, in Elastic, we have we have an ID that is carried right from the service definition to the blueprint, to all the individual requests, and to the operators doing the actual provisioning. So you can see all the events associated with your service definitions through a single Elastic query. Of course, there are custom resources, so you can just go in K9s, for example, here, and check out the status at any time. But some developers in our bank, quite a lot, actually don't really use Kubernetes day to day, so they probably don't even have K9s installed, or even kubectl. So for them, we take advantage of the fact that they are all written in the Backstage format, so we ingest them in Backstage. And then if you go to any application, you can go and see the status that you, basically it's a one-to-one status of what you would see inside Kubernetes. Having it in the Backstage format alongside with the APIs also allowed developers to go to any application and see the relationships that it has, which APIs they interact with, basically, and which APIs they provide for the outside world. And it, of course, has links to the formal API definitions. It also allows architects or developers doing major features across numerous services to see the relationships between services and even see which people are working on it, who are the key people they should contact to coordinate changes. So I want to discuss the challenges we've had with this approach, because there has been some. I would say the biggest one is definitely developer buy-in. We had to do this project essentially because we have to prove with DORA and with this compliance regulation called CFI as well, that we are able to do disaster recovery and we are able to audit, and basically that we are compliant. Still, developer buy-in has been a challenge. What we've done, as you can see, we have a very lean format for our service definitions, is that we have basically proven how easy and fast that it can be, and that has won most over. And then beyond that, we've had a lot of talks basically like this, and also workshops to to get to into the early majority, I would say, and from there, essentially force the rest onto our platform. Equally big challenge, almost, is to integrate with the existing systems and teams. They, of course, have established ways of doing things, and they're not always so happy to do a bunch of work to just enable it in a different way. But what I really found there is to do this kind of integration with teams is to work with them very closely and basically make it into our project. My team and their team together to get this done. We found just taking a sort of initial agreement, and then starting to develop and try to integrate with them is very fragile over time. It's much better to be on the same page and doing it together. Lastly, conflicting requirements. So yeah, it's a very, very lean way of doing it. There's very few configuration options in our approach. So of course we can't satisfy every single requirement that a developer might have. So what we've done there is we spent, I would say, basically the majority of the time to work with developers and find exactly what their pain points are and what they require, what they need to be able to do in terms of this infrastructure provisioning before we even start building any of it. And beyond that, for the last maybe 10 or 20%, we simply have to insist that we have to do it in a unified way so we can be compliant, basically. So just to wrap up, we had manual identity and role assignments, and now they are automated, and they are easy to change and easy to remove also if needed. It was difficult to audit and track compliance, and now it's very easy. It's literally just looking through a single Git repository history. It was drift-prone before, and now with the reconciliation-based approach, it is almost impossible to do drift, since it will just reconcile back to whatever the state is in the service definitions. Of course, with some caveat, you can still introduce drift if you really want to. It was manual and slow, and now it's very fast, literally having gone from, in some cases, months to minutes or at most hours. There was poor feedback, and now they can see they have continuous feedback at any time, including after the provisioning is done. So if something breaks in the future, they will also be able to go and see that. And then lastly, there was very difficult disaster recovery, and now it's very easy and fast. It's literally just spinning up the operators and pointing them to the service catalog. As long as the prerequisites are met, for example, for identity provisioning operator, it's kind of ironically, it needs its identity provision before it can work. Yeah, if you have any questions, I'll be very happy to answer them. And thank you for listening to my presentation. Oh, yeah. Should I give you a microphone or something? Oh. Yeah,
yes, I wanted to ask, why did you decide to use the backstage YAML model, and how did you manage to convince service management teams to use that instead of ServiceNow and similar tools?
Yeah, so we are very engineer-driven, I would say. Most managers are former engineers, and these decisions are taken on the engineering level mostly, I would say. And what I really found, I hope no one is from ServiceNow, I don't want to disparage, but developers are very easy to convince to move away from ServiceNow, I would say. Beyond that, the backstage format, it just fit very well with our use case, and through discussion, we were able to come to an agreement that it was a good candidate for this kind of thing. Is there any other questions?
Did I understand it right that you use Backstage, but only read-only? What's this?
No, that's just in what I showed here. We use Backstage for all kinds of different things. Yeah. Just recently, actually, we integrated with Headlamp, where you can do quite a bit of write things if you want to.
Thank you.
Is there any others? I think that's it. Thank you very much for listening.